In this video, we're going to be comparing the IF out of two FieldFoxes to see if we can use it for a phase comparison. Could you use two FieldFoxes and compare the phase of the IF out? So what we're going to do here as the setup is I have an MXG here. I take the output of my MXG and I'm going to run it through a splitter. And one input goes to the port 2 or SA port of this FieldFox, and the other input goes into this other FieldFox. Everything is locked in the 10 megahertzes. The 10 megahertz reference, the back of this has a signal that is split. And if you look here, you see an external R, system config. Frequency reference is set to external. The same on this. So all the 10 meg references are locked. So I've got this set up to a 1 gigahertz, just a CW 1 gigahertz at minus 10 dBm. Let me preset these so we start from scratch so you know how what the setup is. I'll go into spectrum analyzer mode in both. Center them at 1 gig. And let's do a span of 10 meg. Marker to peak. There's kind of a minus 16 dBm. So that's the two signal. And we have the two IF outs coming and going to a scope. And to turn on the IF out, to make it active in the SA mode, you go to System, you go to Bandwidth, Advanced, IF Output, and I can set it up to wide. There is my IF out. Or you can set it up to narrow. It's a different frequency. One is 33 megahertz, one is 225. But I'll set it up to wide. This is the 100 megahertz. And you also have to be in zero span. That's the setup in SA mode. If I was in RTSA or IQA, I wouldn't have to go to, there's no zero span, it's just as is. So let's do the same on this one. We go to zero span. I will also go to advanced, IF out, and set it to wide. So now they're both connected. Let's start with the default setup of my scope and auto scale so I can see both signals. And let's put these two on top of each other so it makes, first let me turn off the, I want to turn off the timing signals. I think if I turn markers off, track measurements off. Okay, and let's put them on top of each other so you can kind of compare them if you're trying to do a measurement comparison. It makes it easier. 20 and offset of 0, okay, and then channel 2 offset of 0 volts. Okay, just to make it a little bit less noisy, we'll run some averaging. So these are my two IF outs. Now the issue is if you want to track the phase between these two, if I tune, for example, this signal, let's say it's 1 gigahertz now, I'm going to just step up to 1.1, then I go back. You see it's a different location. Keep an eye out on the difference between the green and the yellow as I tune this in and out. It doesn't come back always to the same spot. You see it's shifted over now. It was over here. Let me go somewhere else. Now it's in even a different spot. So the phase difference between these two is not repeatable, and it's also not deterministic. You can't error correct for it. So in summary, if you wanted to use the two FieldFoxes and use the two IF outs to do a phase comparison between for your measurements, this setup won't work because even though the two FieldFoxes the 10 megahertz are locked, the difference between the IF outs is not repeatable, and it's also not deterministic. It's not the same, so you can't error correct it. You could consider using vector voltmeter if that vector voltmeter application works for a phase comparison.